So you should have your part 3 notes. It was the other little booklet that I printed for you, and it should be our change. Our change in linear and quadratic functions. So what we have here, it says, in general terms, we can say that a function increases over an open interval of its domain if the graph rises from left to right on an interval, correct? Because that's how we read a graph, just like you read a book. Likewise, a function is decreasing over an open interval if its domain, if the graph falls from left to right. So I'm going down, okay? Now, it is important that we note intervals refer to x values only, where y values are where we either increase and decrease, are constant, okay? When we're saying where does it happen, x marks the spot. You should never include a y value in an interval, okay? You should never include a y value in the interval, okay? All right, so here you don't have the graph that's talking about it, but this is just a visual of increasing and decreasing. What you do have is the formal notation of how it's written, okay? I thought you guys could do without the graph in this situation. If I thought wrong, I'm sorry, but I thought we were saying, okay. You should have told us that before. I was getting there. You said we don't have the graph. I was like, I was getting there. All right, so the graph is here just to model what the words it's saying. So what this is telling us, it says f is increasing on an interval. So from a beginning to an end. And as it's increasing, our x values are increasing, and so are our y values, right? That's what this is telling us. Your x's are increasing, and so are your y's. A function is decreasing on a given interval if, as your x's are getting bigger, what are your y's doing? Getting smaller. That's the definition of increasing and decreasing, okay? And then for constant, your y's are going to stay the same on that set interval, right? All right, so here we have, consider the function x squared minus 1. We're going to complete the table by simply plugging in and finding those values. And then we're going to find the average rates of change on these given intervals, okay? And then we're going to talk about what do we notice for the average rates of change over the consecutive intervals. The key thing here is the word consecutive. Okay, we only can recognize the pattern with the average rate of change if it is a consecutive interval that we are analyzing. All right. Where's your number 6?
Yeah, it's like a green red to graph.
It's not the right number 6.
We did think
on a different. Un momento.
Yeah, like another
6, 7, no. In the notes that we had. I will fix it. Hold on. Pause. Because you have a piecewise, right?
Yeah.
Okay. But it's all right. Here we go. Let's start over. 1A.3, part 2, change in linear quadratics. We talked about increasing and decreasing over time before. Hopefully, we're all pretty good at increasing and decreasing and understanding where that takes place. Yes. Remember, when you are defining where it's at, you only use your x values because x marks the spot. Yep, it's perfect. I did what I did. All right. Now, this is called a piecewise function. Why is it called a piecewise function? Exactly. I can split it into pieces of different graphs, right? So do you see how our first piece right here is a what? What kind of function is that? A quadratic. Our second piece is a constant, and our third piece is a positive linear equation. So this is called a piecewise function because on an interval is broken into various pieces of different functions. Yeah. All right. So here we go. It says increasing. So we're going to talk about where is it increasing when you're looking at this piecewise function. Okay. So our increase would be
-4.
It has an exact starting place, right? It has an exact starting place. There we go. So we're from -8 to -4. And I'm using brackets because your x marks the spot. Okay, not your y, your x. Okay? And then where else do I increase? From 3 to 6. And I'm using brackets because I am defined at that point. Does that make sense?
Yeah. So if it was negative,
parentheses. Yes. Okay. Which goes against everything I was taught, but according to the AP curriculum that I bought, they're wanting you to use the defining and undefining points, which goes against everything I teach. I repeat again, it goes against.
Wait, wouldn't the second one be 3 to 8, not 3 to 6?
Can someone tell her why it's not 8?
X marks the spot.
X marks the spot, not our Y's. X tells us where we're going, okay? All right, here we go. On the red, our decreasing interval.
wow.
What a great friend you are. Okay. And then our constant. -2 to 3.
That's wild.
Okay. Now, domain. Is this a infinite domain? No, I have a restriction. What is my domain? -8. So we start here, and where do we end? At 6. And I'm defined at both points. So it's from -8 to -6. We also need to be comfortable reading it in inequality notation. Okay. I did not write -6. My line just magically appeared there. We need to be comfortable writing it in inequality notation. Our X is greater than or equal to -8, but less than or equal to 6. Are we comfortable with the inequality notation?
Mm-hmm.
Yes. All right. What about our range? There's an ant trying to learn with us. Get off. Wait. And then we go from -4 to +8. And again, we would write it in inequality notation. Y is greater than or equal to -4, but less than or equal to 8. Okay, so I'm going to write what I looked up on my thoughts. Remember, I told you I was against this, so I went and looked it up, and I'm going to tell you what they wrote as to why we are using brackets at these defined points. Brackets are used, and they need to rewrite all of our Algebra 2 books. Since a function increases and decreases, I did not leave myself any space, or is constant on an interval. And so we're using all of this to mark intervals, is what apparently we're going to be doing for the AP test on intervals. And it eliminates people using parentheses, which still makes no sense. Apparently when we're describing increasing and decreasing and constant.
So you're going to do negative and infinity?
No, you can't contain that.
Okay.
Yeah.
What is
Huh?
Is that like the empty?
Like if it's an open or a gap or a hole,
So we need to go back to notes.
I don't know. I'm gonna double check this. I'm gonna actually email College Board because I feel like that's weird. Like for every class I've ever taught in the past 13 years of teaching, your intervals have always just been parentheses because you're not defining anything. You're just describing. Does that make sense?
Yes.
And I don't like that this is trying to change my learning. I'm no. Yeah, why are we changing it? Like it's in my college algebra notes and everything that parentheses define your intervals of increase and decrease. We can't. I just don't want to. Okay. All right, here we go. This is the right graph, right? Okay, so on here, just to make sure that we're comfortable, I'm going to keep reiterating things that we learned because guess what? This knowledge is supposed to last all the way till May, right? So even though it becomes repetitive, I just want to make sure that we are comfortable finding it, okay? I would like for you to find algebraically the average rate of change from -1 to 3 and graphically also verify the average rate of change from -1 to 3, okay? Why? Because we cannot lose this knowledge. Yes, you're doing it yourself. You're doing it yourselves. I need to make sure that we're still okay with carrying over information, especially when you have to build on it.
Oh, I did.
So you're going to find it quickly. You're doing A. All I ask you is for A right now. I get a negative. All right, so let's see how we did. So algebraically, you should have found the value of -1. The value of -1 is what? -4. What's the value at 3? 4. So now I have 4 minus -4 divided by 3 minus -1, which gives me 8 divided by 4, which equals 2. Verifying graphically, I'm at -1, -4. I'm at 3, 4. And I'm asking, how can I get from here to there? That's your rise over run, your average rate of change. So we're going 1, 2, 3, 4, 5, 6, 7, 8. I went up 8. 1, 2, 3, 4. I went over 4. 8 over 4 equals 2. Do you see how we verified that graphically? Yes? Okay. All right, on to the next part. Actually finding the equation of the line that connects these 2 points. Again, that is the straightest line you've ever seen.
OMG.
I know, it's beautiful. Okay, going back to Algebra 1, how do I find the equation of the line given the 2 points? Well, I know my 2 points. My 2 points that I have are -1 and -4, 3 and 4. What is the first thing you have to find? Is your slope. Have we already found our slope? Yes, because our slope is our A-rock. And what was our A-rock? 2. Yeah. After I find that, I just got to find my what? My y-intercept, because we need to be in y equals mx plus b. What we're going to review here is point slope form. Okay? Point slope form is y equals m times x minus x1 plus y1.
Wait, Miss Jones.
Well, how what?
I don't remember that. How come we used -4 instead of 4?
Because it was at -1, -4. And this was at 3 and +4.
Wait, what is
That's for quadratic, the vertex form. H and K. Yeah. All right. This is point slope form for a linear. And you can choose whichever X and Y you want. It does not matter which one. I either can use the first set, the second set. It does not matter. I repeat. So if I chose to use 3 and 4, I can use 3 and 4. I'm going to use 3 and 4 because they're both positive. Does that make sense?
Yeah.
I'm plugging in. So we have y equals 2 times x minus 3 plus 4. Can I simplify that to find my equation of my line?
Yes.
So we have y equals 2x minus 6 plus 4, which means that my equation, oh, I gotta use our math symbols. Then and therefore, our equation of our line is y equals 2x minus 2.
So do we just have to memorize that equation of y equals m x minus x with y?
Point slope, yeah, it's from Algebra Uno.
It's y equals mx. Are you on the pastor?
I didn't see a formula chart. I'll double check, but I didn't see one when they gave me my packet of stuff. So I'll double check though. All right. And then we sketched out our secant line and we could verify all that we just did. If your teacher had drawn her straight perfect line, pretend that I went through -2. It's been verified. We did it right. Good job. Okay. I went through -2. You just didn't see that I went through -2. Okay. Yeah, it's there. It's all there. All of it. Okay. Drawn beautifully for you. Can you do that? Can you use your AROC and point slope to find the equation of a secant?
Yeah.
Okay. Now, looking at it from a table. So the table we have here, it's the function h of x. Notice that I do not have an actual h of x equals blah, 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 right? And it's from 0 to 4. And it tells us that our average rate of change is 18. So it's telling us our average rate of change. It says average rate of change of h of x on this interval is 18. So we know that our AROC equals 18. It wants us to find the missing number. We're going to have to set up and find the missing number. Okay, so we know that 18 equals the change in our y over our change in our x, because that's our average rate of change. Okay, now if we're looking for 4, the only consecutive number that we have is 3. So from our table, we're only using this information. Right? Does that make sense? Okay.
I said x minus 2. Yeah. 0.
Yeah. Oh, you did it from the beginning?
Yeah, well, I just set it up like as a rock for like equal 18 and then put an x.
Yeah. Yeah, that's what you're gonna do. Okay. Yeah. I just haven't wrote it out yet. Oh. No. I said we're now gonna plug in and solve for it. I just wasn't gonna use x, so I didn't want to confuse anyone. Okay. There's just so many x's, so I wasn't gonna use x. So here, this is my unknown y, right? So I'm just gonna call this guy y because x is what we know our x is, and I didn't want to confuse anyone by writing it in there. So when I set this up, it's gonna lead me to we have y minus 34, because changing my y over 4 minus 3 equals 18. The setup is the hard part. Does that make sense? After you set up, this is basic math. Yes? No, maybe so? Yeah. Okay. So when I do the math, I have y minus 34 over 1 equals 18. So y minus 34 equals 18. And we get y equals what? And why is that? Because we just had to add to the other side. So we get y equals 52.
Okay.
Is that terrible? Doable?
It was terrible earlier.
Okay. Okay. You're just remember you're given the value of your AROC, right? But I'm missing a piece. I'm missing my y. So since I'm missing that y, I'm going to plug in everything that I know to solve for that y. Yes? Any questions, comments, or concerns on doing it? No?
No.
Okay. So we're good to go? All right. Here we have, so we're given an equation. We have 2/10 x squared plus 1 and 1500 x plus 5 and 4/10, where x is a given in units of 1,000. Okay. Find the average rate of change in demand when the number of items demanded increases from 2,000s to 4,000s. Just because it's a word problem, is it really a hard problem? No, we're still doing what? Average rate of change. We're still subtracting and dividing, but we have to know what we're subtracting. The thousands represent my what? X. So we know that X is 2, but we do not know what it produces. We know that X is 4. No, because it says your X is given in the unit of 1,000. So I'm plugging in P of 2 to find my said value. So when I plug in P of 2, that's 2/10, 2 squared, plus 1 and 1/1500 times 2, plus 5 and 4/10. Then we have 2/10 times 4 squared, plus 1 and 15 times 4, plus 5 and 4. Okay, I already did the math for you. So we're just going to go ahead and do it. So we end up with, I think I got 8.5, 8.5 here. And I got 13. Well, okay. That's a 3.
Is it?
It is. I don't know what happened. 13.2. So now, do I have everything I need to find my average rate of change?
Yes.
Yes. So to find my average rate of change, I have
13.2. Wait, why don't you do 8, 2, and 4?
There we go. And then 4 minus 2. If I have $13.20 and I spend $8.50, I'm left with $4.70. So 4 and 7/10 divided by,
What is that number in the red?
It's a 13. My pen did weird things. It's a 3.
Okay, thank you.
Yes. Did you not see it like stagger? And then erase and I had to write it back? Okay, it's recorded. You can go see it. Yeah, that's what it looked like. If you have $4.70 and you split between 2 people, how much do they each get?
$2 and
35 cents. So our A-Rock is here. All right, making sure you understand. Please do example 9B at your table and check with your peers. So example 10 was supposed to be our exit ticket. We exit in 3 minutes and 25 seconds. Yes. All right. Are y'all ready to tell me?
No.
Okay. On the first one?
Or on P1?
On P1, I got 6 and 7,500.
Yes,
You got what? I got 6.75. I was like, did someone get something that I got? Because I didn't hear y'all say my number. 1 squared. It's 1 squared times 0.2. Because your X is 1. It'll just be 0.2. No, you already used the square on the 1. So I ended up with 6 and 75, and I ended up with 16 and 1,500s. So we have 16 and 1,500s minus 6 and 7,500s all over 5 minus 1. And I get 9 and 4/10 over 4, which if you want to keep breaking down, you could, but just divide it and you get what? 235. So that means that these lie on the same direction, the same interval of change, or have the same interval of change. All right. So the plan was for the rest of the period, you're going to work on example number 10, applying your knowledge that we've talked about in the past 2 days. Came so close. Yes, ma'am.